All right, so let's get right into it. For a long time, the story of AI seemed, well, pretty simple. But then, in one single week, back in January 2026, it felt like the entire rulebook just got torn up. We're talking about a moment that literally shifted the ground under the feet of the whole tech industry.
See, the thinking was always straightforward. Bigger is better. Simple as that. The company that had the biggest AI model, the one with the most parameters, they were seen as the king of the hill. It was basically an arms race, but instead of weapons, it was all about sheer size and computing power. But then this quote dropped from NVIDIA's CEO Jensen Huang, and this one little line, it signaled that everything was about to change. The game wasn't just about digital chatbots anymore. Oh no, AI was about to get a body and start moving around in the real world.
So what happened? How did we go from this race to build the biggest brain to a flat-out battle to build the first true AI empire? That's exactly what we're going to break down right now. Okay, so it all starts with a huge revolution in the tech itself. I mean, the very idea of what makes an AI powerful got completely flipped on its head.
So let me introduce you to Falcon H1R. It's got just 7 billion parameters. Now its competitor, Abriel 1.5, has more than double that at 15 billion. So based on the old rules, this shouldn't even be a fair fight. The bigger model should win, no question, right? Well, take a look at this. This chart shows the new reality perfectly. On a really complex math test, you can see the smaller Falcon model, that's the bar on the left, is actually beating the larger one. This was the proof. Smarter design could totally beat brute force size. All of a sudden, efficiency and quality were the things that mattered most.
Now, the secret sauce here is this really cool innovation called DeepConf. It basically lets these smaller models check their own work, filtering out bad or unreliable answers. So what's the big takeaway? They're not just smaller and faster, they're also reliable enough to be used for really critical, real-world stuff.
So with this new, way more efficient technology out there, the big tech giants saw their opening. They weren't just building better tools anymore, they started building actual empires.
And then the first bombshell dropped. Apple, the company famous for its walled garden, its closed ecosystem, announced it was partnering with its biggest rival, Google. Google's Gemini AI was going to be the new brain behind Siri. Just wow.
Let's just break down what a massive strategic move this was.
For Apple? Yeah, it was a way to catch up fast, but it meant they were suddenly depending on Google for a core part of their experience. For Google? An unbelievable win. They got instant access to over 1.5 billion devices. And for companies like OpenAI, well, they were suddenly on the sidelines, losing a ton of leverage.
Meanwhile, you've got Meta playing a totally different game. Mark Zuckerberg basically said their strategy wasn't just about having the best models, it was about owning the physical foundation of AI. They were treating infrastructure, we're talking data centers, power, everything, as their competitive advantage.
And the scale of this bet is it's staggering. We're talking $600 billion being invested in US infrastructure by 2028. Meta isn't just buying computer chips anymore. They're building the power plants and the data centers to run the entire future of AI.
And to put that number in perspective for you, just one of their data center projects, a thing called Hyperion, needed $27 billion in financing. That's for one project. This isn't a tech race anymore. It's an infrastructure and capital race, and it's on a global scale.
So, okay, you've got these smarter brains, and you've got these massive empires building out the infrastructure. What's the next logical step? Well, you give that intelligence a physical body to actually go out and do things in the world.
This is all possible because of a new kind of AI called a Vision Language Action Model, or VLA for short. Think of it like this. It can see the world through a camera, decide what to do physically, and, this is the really crucial part, it can explain why it made that choice. That's something you absolutely need for things like self-driving cars.
And then at CES 2026, we saw the incredible result of all this, the Boston Dynamics Atlas robot. And as you can see, this is no longer some cool research project. It's ready for the factory floor. We're talking fully rotational joints, hands that can feel and touch. It's a machine designed to work alongside people and maybe even do things humans can't.
And it wasn't just Atlas. Physical AI was everywhere. From smart home robots and vacuums that can climb stairs to actual humanoids designed to do chores around your house. The jump from the digital screen to our physical reality was happening, and it was happening fast.
So, what does this all add up to?
When the technology, the business strategies, and the real-world applications all change at the same time, you get a completely new set of rules for who wins and who loses. The money is all flowing to something called Agentic AI. These are systems that can handle complex, multi-step tasks all by themselves. And look at this market. It's projected to grow almost 40 times in just a decade. This is the economic engine that's driving this whole race for empire.
So all of this leads to a brand new playbook. Let's just walk through it. First, owning the infrastructure. That's the ultimate bottleneck. Second, the value is shifting to inference. That's the cost of actually running the AI every day, not just training it once. Third, controlling your own hardware and software gives you massive leverage. And finally, companies are using open source models as a way to get developers hooked into their ecosystem.
But, and this is a huge but, this new era comes with some massive risks. You've got power getting concentrated into the hands of just a few giant companies. Apple has made itself pretty vulnerable by relying on Google. And for all the cool robot demos, actually making them work safely and profitably in the real world, that is still a huge unsolved problem.
Which really leaves us with the ultimate question. In this new age of AI empires, with these massive structures of data, infrastructure, and physical robots taking shape, who actually holds the power? Is it the company with the smartest code, the biggest data center, or the one with the most robots on the ground? The answer? Well, it's not so simple anymore.